Hello there, ladies and gentlemen. Today we're going to be talking about logarithms. What are they? What are some things we can know about them? And why are we talking about them in this course? So logarithms, what is a log? Okay, so the logarithm function is the inverse function of an exponential. Okay, so we started this chapter talking about inverses, and then we talked about exponential functions. And the reason why we did that is because we were eventually going to be talking about these log functions, which are the inverse of exponentials. So if you compose them with an exponential, you will get a x, okay? And then if you were to solve for y on each one, you would end up with each other, okay? Now, the definition of a log, we actually define it by thinking about an exponential, okay? If you have the log of a function, okay, so y equals log base a of x, okay? So literally this word log, it's not variables, it's the operation. The operation is called the log, okay, the logarithm, okay? If I take the log of a number x, what that really means is x equals a to the y. Basically, when I have the log with a base of some number, what I'm asking myself is, hey, a to what exponent would give me the inside, okay? A to what power gives me x? So that's where we're getting the y from. And that's where this is coming from over here. A to what power gives me that inside? For example, if I had the log base 2 of 4, what I would be saying is, okay, 2 to what power gives me 4? Okay, 2 to what power gives me 4? And the answer to that would be 2. Okay, 2 to the second power gives you 4. That's what the log base 2 of 4 would be. Okay, we have a lot of different bases we can use for log. Okay, a can be any number you can think of. We can do log base 7, log base 20, log base 100, whatever, okay? With these log bases, you're going to see a lot of the times we're going to use two of them in particular. We're going to use 10 a lot, and we're going to use e a lot, but we'll talk a little bit about that later as we go, okay? Here's another example. Hey, log base 2 of x equals y. What about when x is 32? So the log base 2 of 32, what that is asking is, hey, 2 to what power gives you 32? And the answer to that would be 5. Okay, 2 to the 5th power gives you 32. So we could actually kind of rewrite this answer using an exponential. We can say, hey, you know what? The same sort of thing written as an exponential, 2 to the 5th power would equal 32. Okay, if I take 2 to the 5th power, I get 32. All right? You guys go ahead and try. So go ahead, pause video. You try this one. When we come back, we'll go over what the answer should be, okay? All right, so hopefully you came back. Let's go ahead and talk about this one. So the log base 3 of 1 equals y. And so my question is, all right, well, 3 to what power will give me 1? And the answer to that actually is 0. So y would equal 0, okay? Which makes sense. We think about it. Again, I kind of like to draw these arrows to help me with this, but 3 to the y should equal 1. So what we're saying is that 3 to the 0 equals 1, which is definitely a true statement. 3 to the 0 power does equal 1, okay? This fact right here is true of every logarithm of its base, right? If the inside is 1, if I put 1 in my log, it's going to equal 0, okay? That's going to be true for all logarithms, okay? Here's the graph of the logarithmic function. As you'll notice, it looks like the exponential function, but all the x and y's are flipped, which fits with our inverse thing, right? Domain and range flip-flop with each other, okay? The important point for the logarithmic function is going to be the point 1, 0. In fact, we just saw that on the last slide. When we plug in 1 for x, we're going to get out 0. Similar to the exponential function, when you plug in 0, you get out 1, okay? So this is generally what it looks like. Again, looks a lot like an exponential function where the x and y's were flip-flopped, okay? Shifting the logarithmic function, again, h is going to move you left and right. K is going to move you up and down. Okay, so left and right. I don't even think I need to write this. K is going to go up and down. We could have negatives out front that'll flip you left and right, or flip you your graph. Again, deja vu, same sort of transformations for all our functions. We saw this way back in one of our earlier chapters when we talked about the parent functions and how they move, okay? Now, I told you guys there's going to be 2 logs that we're going to see a lot more than the other ones, okay? The first one actually is log base 10, which we just write as the log of x, okay? That means the log base 10 of x. Basically, we use base 10 a lot, So mathematicians got lazy and they're like, you know what? We're tired of writing the number 10. So if we don't write a base, just assume that it's base 10. Okay, so if you ever see log without a base, it is base 10. That's what it means. Okay, in your calculator, you actually see that there's a log base 10. It just says log of x. That's doing base 10. All right. The other logarithm we use a lot is called the natural log. That's a log with base e. Now, you can already kind of guess from talking about exponential functions. In the finance world, e comes up a lot, right? We saw all those equations that involved e. So in logarithms, again, e is going to come up a lot. So we're going to use this function right here. And they got tired of writing log base e. And they already had log taken up by base 10. So mathematicians said, hey, we're going to get lazy. We're going to call it ln, okay? ln is standing for the natural log, okay? So ln is the natural log. This, all it means is log base e. Okay? Again, just remember, the word log, L-O-G, is just the name of what you're doing. It's called the log function, okay? We're doing the log of this, all right? So base e is going to be the natural log, written ln, okay? All the same properties, just used a lot of applications, okay? Here's one application that we could do, right? So we have students participating in a psychology experiment. They're going to attend several lectures on a subject, and they're going to be given 12 exams. The students are then retested to see how much of the material they retained. The average score in each retest is given by the following, okay? So basically what's happening is these kids go to a lecture, and then they're given a test, and then they're given a test 11 more times. So it ends up being 12 tests, and as they go, their scores go down, and we're trying to see how much their scores go down by. Okay, what happens as they go down, all right? So what you guys are going to do is you're going to put in 0, 2, and 6 and see what happens to the score as they go. So on everybody, you're going to need to take a calculator. You'll see a natural log on there. You can use that. Okay, go ahead and plug those in and tell me what you get for after 0 tests, okay, the original test, and then 2 tests, and then 6 tests. Okay, and we kind of see our scores here. So the original test, the average score was a 75. Then after 2 months, it went down to a 68.4. Then after 6 months, it went down to a 63.3. Again, logarithms kind of have that kind of gradual decline as they go. So we can kind of see that these scores are going down, but they're going to go down less and less as we go. Kind of getting to like, here's the knowledge that these people will know forever versus the stuff they just know when they take the test the first time. I think you guys have all experienced that. You study really hard for a test, you do well on it, and then a month later, you maybe know 60, 70% of what you knew on that test, but some of that stuff's gone. Okay, that's sort of slow decline of knowledge of, okay, here's the stuff I might know forever, and here's the things that I knew for the test that I'm not going to remember further, okay? Just to kind of show you guys, if you can see my camera here on your calculator, you'll notice on the very far left, that's where you're going to find your logarithm button. So there's that natural log button, there's that log button. Okay, oh, I hit something, yeah, syntax error. Okay, but if you, you can see where I type this in. Okay, just type it in your calculator, put it in, and you should get the answer that I got there, okay? That is our introduction to logarithms. Thank you all for watching.